Hi, this is Reddy. Welcome back to ReddyControls. Have you ever noticed some PLC outputs stay on even after the power is cycled? That's because of these two instructions, the output latch and output unlatch. These instructions are called as retentive bit outputs, and depending on how you use them, they can either make you smarter or more dangerous. Let's look at both sides of this. OTL stands for output latch. OTU stands for output unlatch. They remember the latch state even when the rung goes false or the PLC restarts. They remember the state. That's why they call it as retentive bits. In this example, I have a start button doing a motor run command latching, and I have a stop button that unlatches it. So if I go ahead and push the start button, the motor run command is on, and at this point, even if I lose power of the PLC or the PLC goes into a program mode, when it comes back up, the motor run command stays on until we push the stop push button. So when I go ahead and push the stop push button, the motor run command is unlatched. Now imagine that this rung is controlling a large conveyor or a press, and if the plant loses power and someone is working on it, the moment the power turns on, the OTL energizes the output automatically. Again, this causes an unexpected motion, which is a major safety hazard. That's why most control engineers use a ceiling logic, which is with a normal start-stop circuit. It resets safely when power is lost, and that's shown here. You just have a start push button and you seal in the motor run. Start being a momentary normally open, we use this sealing logic, and whenever we start and if you lose power, the stop push button will drop, which will drop the motor run command. So that's more of a intentional restart during power outages. For example, say we want a cooling fan or a tower fan to come on immediately without any reset. That's when we use logic like this, where you have a cooling tower enable bit that turns on the tower fan, and when we lose power and on the power up, for critical systems we might need a logic like this, like cooling tower fans that must come back immediately to prevent thermal runaway, or a lubrication or a cooling pump that protects the bearing, or exhaust fans in chemical process that maintain ventilation. In these cases, the OTL and OTU or any retentive bits is perfectly fine, as long as you have done a risk assessment and the restart will not endanger people. Here, if the power returns, in this example, even in here, if the power returns, the fan restarts automatically, but only if the safety trip contact is clear. This is called as a controlled restart. So how do you decide when to use an OTL and an OTU? Use the retentive outputs OTL and OTU for memory logic, like fault alarms or process flags that needs to stay latched until reset. Use them for a controlled auto restart system where safety interlocks exist. Avoid them for motion outputs or anything that could start unexpectedly after power up. Always combine with feedback, interlocks, or separate system ready rungs before energizing. So yes, OTL and OTU can be dangerous in wrong place, but they're essential in the right place. It all depends on what happens when power comes back up. Program smart, stay safe, and keep learning. Follow at ReddyControls for more practical Studio 5000 lessons. In the next video, if you have missed my previous video where we talk about non-retentive bits, the link will appear on the left side. Until then, see you in the next video.